All right, this is lesson 1.33, and it's on partial fractions, A-level pure maths, year 2. In this lesson, we are going to learn how to split algebraic fractions which have quadratic factors in their denominators into partial fractions. In previous lessons, we have learned how to split algebraic fractions which only have linear factors in their denominators, like this one. These factors here, x plus 1 and x minus 4, are linear because they are in the form ax plus b, where a and b are constants. So in the case of this one here, the a is 1 and the b is also 1. In this case, the a is 1 and the b is minus 4. And we learned that in such cases, you split a fraction into partial fractions as follows, where a is a constant over a linear factor and b is also a constant over a linear factor. And that makes the two fractions proper fractions because the degree of the numerator is 1 less the degree of the denominator. So what happens when we have a fraction like this, where the denominator is quadratic? And this is quadratic because it's in the form ax squared plus bx plus c. I'm going to show you some more cases where the algebraic fractions have quadratic factors in their denominators. So the second one is this one. In this case, x minus 3 is linear and x squared plus 9 is quadratic. And the third case, we have x minus 4 being linear and 3x squared plus 4x plus 2 being quadratic. And I've given one where you have a cubic here. So in this case, we have a linear here and a cubic here. Just to show you how we're going to split that one as well into partial fractions, in case you have a cubic factor in the denominator. Whenever you have a quadratic factor in the denominator, the first thing you do is to check if you can factorize it. And you can easily do that by finding the discriminant of the quadratic factor. In this case, the discriminant, which is b squared minus 4ac, will be 36 minus 4 times 1 times minus 27. And that gives 144. This is 12 squared. This means that 144 is a positive perfect square. And because it's a positive perfect square, this quadratic expression can be factorized. So x squared plus 6 minus 27 can be factorized as follows. X minus 3 and then x plus 9 over here. We can therefore rewrite this one and split it into partial fractions accordingly as follows. And then we use either the substitution method or the comparing coefficient method to find the values of a and b. Now in this case here, the discriminant of the quadratic here will be 0 minus 4 times 1 times 9, and that gives minus 36. And this is not a positive perfect square. And so we have to find another way of splitting this into partial fractions. In such cases, we split it up as follows. So a is a constant over the linear factor. Then we have a linear numerator over a quadratic denominator. And this is because the degree of the denominator is 2 and the degree of the numerator is 1. And that guarantees that the whole of this fraction is a proper fraction. And so from here, we can proceed and use the same principles of either the substitution method or the comparing coefficient method to find the values of a, b, and c. In this case, x minus 5 is linear and this one is quadratic. So we use the same principles and are going to split it in this way. So a constant over x minus 5 plus a linear function over a quadratic function over here. In the case of this one here, this is cubic. So we have the following. We have a over x plus 1, which because x plus 1 is linear. And because this is cubic, the numerator must be a quadratic. And that's where we have bx squared plus cx plus d over this cubic denominator. And this is how we split partial fractions up when the denominator is not linear. So we're going to go ahead and solve this question here using the same principles that we've learned before. So we are going to find the values of a, b, and c in this case. And we are going to use the same principles, and we will multiply both the left-hand side and the right-hand side of this equivalent relationship by the denominator of the hand side. And if I do that, I'm going to get the following. So at this point, we are going to do some cancellation. We can see that this will cancel with that. That will cancel with this one as well. And x minus 3 will cancel with x minus 3 over here. And x squared plus 9 will cancel with x squared plus 9 over here. And then we'll be left with 10x plus 6 on the left-hand side. And a brackets x squared plus 9 plus bx plus c, all of that times x minus 3 on the right-hand side. So this is a point where we can proceed by using either the substitution method or the comparing coefficient method. On this occasion, I'm going to use the substitution method to find the values of a, b, and c. So I'll let x equals to 3. So in that case, the whole of this term will be eliminated because 3 minus 3 is 0, and 0 times all that will be 0. And I'll have 3 times 10, 30, plus 6, 36 on the left-hand side, and I'll have 18a on the right-hand side. So I get the following. And this implies that a is equals to 2. Then I'll let x equals to 0. So in that case, if I do my substitution, I'll get the following. And then simplifying will give me 6 on the left-hand side and 18 minus 3c on the right-hand side. 7 for c will give c equals to 4. Then, so I've got the values of a and c. Now we need to get the values of b. And I can choose any number to do the substitution. It's easier for me to choose a smaller number, so I'm going to let x equals to 1. And in that case, I get this. And then simplifying will give me 16 equals to 20 minus 2 times b plus c. Because if I put 1 here, I'll get minus 2 times b plus c. And then simplifying that, I get the following. But I know the value of c to be 4. So I do the appropriate substitution and then solve for b to get minus 2. So now I can write my full equation in terms of partial fractions as follows. A, we've got to be 2, so that's why I've got 2 over x minus 3 here. And b, we've got to be minus 2, and that's why I have minus 2x here. And then c was 4, and that's why I have 4 over here. But I can write this nicely as follows. 2 over x minus 3 plus 4 minus 2x all over x squared plus 9. And this is how this can be split into partial fractions. We are now going to solve 2 more questions involving algebraic fractions which have quadratic factors in their denominators. So let's go and do that. So x squared over x minus 1 times x squared plus 1 will be split up as follows. A over x minus 1 plus bx plus c over x squared plus 1. Then I'll multiply all the 3 terms by the denominator of the left-hand side. And I'm going to get x squared on the left-hand side, and on the right-hand side, I'll have the x minus 1 will cancel out, and so have a brackets x squared plus 1 plus bx plus c times x minus 1. And then I'll do the appropriate substitutions. So say when x is equals to 1, then the whole of this term becomes 0 because x minus 1 is 0, and 0 times all that becomes 0. And I will have 1 squared, which is 1, on the left-hand side equals to 1 squared is 1, 1 plus 1 is 2, so I'll have 2a here. And this implies that a is equals to half. Then when x equals to 0, then on the left-hand side, I'll have 0 equals to 0 plus 1. 1 times a is a, plus, and for this term, I'll have 0 times b is 0, so I have c in this bracket, and then I have 0 minus 1 is minus 1, so minus 1 times c is minus c, so I have minus c. But I know the value of a, which is half, so I have 0 is equals to half minus c, which implies that c is equals to half. Now choose another value for x. So when x is equals to c minus 1, then I'll have minus 1 squared, which is 1 on the left-hand side, equals to minus 1 squared is 1, 1 plus 1 is 2, and so I have 2a here. And then for this term, I'll have minus 1 times b is minus b, and then minus 1 is minus 2. So I'll have plus brackets minus b plus c times minus 2. But we know the values of a and c. So if you do the substitution, we're going to get 1 is equals to 1 because half times 2 is 1. And I'll have minus 2 times c is half, so I have half minus b. And then when I take this one to that side, I'll get 0. So I'll have 2 brackets half minus b is equals to 0, which means that half minus b is equals to 0, which implies that b is equals to half. So now I've got the values of a, b, and c. So I can write up my fraction as partial fractions as follows. So x squared all over x minus 1 times x squared plus 1 will be equal to half for a over x minus 1 plus half for b, x plus half for c all over x squared plus 1. We can simplify that further by saying 1 over 2 brackets x minus 1 plus half brackets x plus 1, all of that over x squared plus 1. And finally, we can write this as x squared over x minus 1 times x squared plus 1 is equal to 1 over 2 brackets x minus 1 plus x plus 1 all over 2 brackets x squared plus 1. And that's the final answer required for this question. Question 2. 15x squared minus x plus 2, all of that over x minus 5 times 3x squared plus 4x minus 2 is equal to a over x minus 5 plus bx plus c over 3x squared plus 4x minus 2. And using the same principles, I'm going to multiply all the three terms by this denominator right here. So if I do that, I'm going to be left with 15x squared minus x plus 2 on the left-hand side equals to a bracket 3x squared plus 4x minus 2 plus bx plus c times x minus 5. And then I'll do my substitutions appropriately. And so first, let x equals to 5. So when x equals to 5, the whole of this term becomes 0 because 5 minus 5 is 0, and 0 times all that is 0. So I'll be left with 372 on the left-hand side equals to 93a on the right-hand side. And this implies that a is equals to 4. Now let x equals to 0. So when x equals to 0, on the left-hand side, I'll get 2 equals 2. This will be 0, that will be 0, so I'll be left with minus 2 in the bracket, so I'll have minus 2a. And this will be 0, and I have minus 5c, so minus 5c. But I know the value of a, so if I do my substitution, I'll get 2 equals to minus 8 minus 5c, which implies that 5c is equals to minus 10. That means c is equals to minus 2. The next, let x equals to 1. So when x equals to 1, then on the left-hand side, I have 16 equals to 5a minus 4 brackets b plus c. But I know the values of a and c. So if I do the substitution, I have 16 here equals to 20, because 4 times 5 is 20, minus 4 brackets b minus 2. So this means that 4 brackets b minus 2 is equals to 4. That means b minus 2 is equals to 1, which implies that b is equals to 3. So now I've got the values of a, b, and c. My fraction becomes 15x squared minus x plus 2, all of that over x minus 5, 3x squared plus 4x minus 2 will be equals to a we got to be 4, so 4 over x minus 5 plus b we got to be 3, so 3x, and c we got to be minus 2, so minus 2, all of that over 3x squared plus 4x minus 2. And that is the required partial fractions for question 2. And this brings us to the end of lesson 1.33 on partial fractions. Thank you again for watching. See you in the next video.